Hi guys, let's look at nomenclature of aromatic compounds, in particular benzene compounds. We'll first look at systematic nomenclature, which we'll use when we have just halogens or nitro groups on the ring. We'll also see that we can use common names when we have other substituents on the ring. First, systematic. Okay, when you have a halogen on the benzene ring, the compound is simply called a halobenzene, with halo being either fluoro, bromo, chloro, iodo. And so this compound here with the one fluorine on the benzene ring is called simply fluorobenzene. Compound here, simply called bromobenzene. Now the halogen can be at any position. No matter where it is, it's just bromobenzene. It's just the compound rotated. Pretty straightforward. Now if we have two halogens, we now have the potential for isomers. In this example, we have two chlorines. The chlorines can be in a 1-2 relationship. That is, if this is 1, then the next chlorine would be at the 2 position. And I could have did this the other way. I could have called that 1 and that 2. It doesn't matter. And so that we can call this 1,2 dichlorobenzene, with the 1,2 being where the two chlorines are positioned. The isomer here would be 1,3 dichlorobenzene. Because if that's 1, that's 2, the other chlorine is at the 3 position. And then this isomer here would be 1,4 dichlorobenzene. Now we can also use some prefixes to denote the relationship between the substituents. And as we'll see here, when the substituents are in a 1-2 relationship adjacent to each other like this, that's called ortho. And thus an alternative name for 1,2 dichlorobenzene could be ortho dichlorobenzene. Let's look at these prefixes that can be used. These prefixes can be used in the manner I described up here, and we'll name these other two using this terminology. Ultimately, though, these prefixes are used to name the positioning of a substituent relative to another. Let's look at this. Relative to a substituent. The carbon that a substituent is on is called the ipso carbon. Now, ipso is not a common term. You're probably not going to see that in your textbook. The other three are highly common. We will see ipso on the NMR tables that we will be looking at for the sulfanilamide lab. Okay, the position next to where the substituent is located is called the ortho position. And sometimes these can be designated with simple just the letter in parentheses. The next position compared to the substituent, that is not adjacent but the next one, if this is 1, that would be 2, not 2 but 3, that's referred to as the meta position. Meta. And then the fourth position, or the fourth carbon from the substituent, is your para position. Very important terminology, much used. So we go back up here. This is ortho-dichlorobenzene. This could be called meta-dichlorobenzene because the chlorines are in a meta relationship. Or if you focus on one, the other one is in the meta position. If we focus on this one, the other chlorine is in a para position. It's a para relationship between the two, and this can be called para-dichlorobenzene. By the way, this compound is used as mothballs. You can buy it at Walmart in the laundry section. If you look at the back of the box, you'll probably see the name para-dichlorobenzene, or it may just say p-dichlorobenzene. It would be a more official name to name it with the numbers, and I would stick with naming it with the numbers as more IUPAC systematic nomenclature, but certainly the prefixes are commonly used. Okay, let's bring in the nitro group, the NO2 group. We'll be seeing this. We'll see how to synthesize nitro compounds, how to nitrate a ring. You'll be nitrating a ring in the lab soon, often using nitric acid. When you have a nitro group, it's simply named as a substituent on the benzene ring. So this compound has two substituents, a bromine and a nitro. Those are going to be placed in alphabetical order. First, we need to number this. Subs always get lowest substituents. This is a 1-4 relationship, which is 1. Well, either way you go, it's 1-4. Somehow we need to break the tie. Alphabetical. Since B comes before N, we're going to call this carbon 1, 2, 3, and thus that carbon 4. So the bromine's at the 1 position, and the nitro's at the 4 position, benzene. We list these in alphabetical order. Of course, subs are getting lowest numbers here. You would never start here, call that 1. If you did, the bromine would be 2 and the nitro would be 5. 2, 5 is not as good as 1, 4. Thus, you're always going to start, or the 1 position will always be where a substituent is located. Let's try the next one. Halogens and nitro groups. We just named these halo groups and nitro groups. We have a bromo, an iodo, and a nitro. Eventually those are going to be placed in alphabetical order, but numbering. If the bromine was 1, the iodo would be 3, and the nitro would be 4. That's a 1, 3, 4 relationship or numbering sequence. We can do better than that. If the nitro is 1, then the iodo would be 2, 3, 4. And that's a 1, 2, 4. And that's better than a 1, 3, 4. Now we could also perhaps start with the iodine being 1. If that was 1, we would go towards the nitro and let it be 2. 1, 2. But the bromine would not be until 5, so that would be a 1, 2, 5. And a 1, 2, 5 is also not the best. There's only one way to get a 1,2,4, and so we don't have to break the tie in any way like we did above by using alphabetical. The numbering is set. We place the substituents in alphabetical order, but the bromine's at the 4 position, the iodo's at the 2 iodo, 1 nitro, benzene. Now the ortho meta para terminology could be used here, but we would never use it in our name here because it's too ambiguous. You only use ortho meta para when there's 2 substituents. When there's 3, it just doesn't work out. You can't call this para because how do you know which groups are para? Yes, the bromine and nitro group are para. Yes, the bromine is meta to the iodine and para to the nitro group. So you can use the terminology to sort of discuss your compound, but we can't use that terminology in this name since we have more than 2 substituents. Question: which carbon of the benzene ring is para to the iodine? Well, it would be that carbon there that's para to the iodine. Which substituent is ortho to the iodine? Well, again, that's straightforward. The nitro group is ortho to the iodine. The bromine is meta to the iodine. Convenient terminology. By the way, these terms were first introduced by Korner, a chemist, who was a student of Kekulé back in the mid to late 1800s. Kekulé being the chemist who first proposed the correct structure of benzene. Okay, so these were so-called systematic names, just naming the substituent on the benzene ring. Next, let's look at common names. Many of the monosubstituted benzene compounds have common names, and there's 7 here that I want you to know. First one, benzene with a methyl group. We may call this methylbenzene, but nobody calls it methylbenzene. It goes by the common name of toluene. And toluene is actually a very common solvent in the lab. It's also sold at Lowe's and Home Depot in the paint section. It's used as a solvent for painting, such as for thinning paints or washing oil-based paints. It's much less toxic than benzene. The methyl group makes it less toxic than if it was just benzene. Next is anisole. Anisole has a methoxy group on the benzene, O-methyl. Sometimes used as a solvent, but nowhere as common as toluene as a solvent. It's a specialty solvent, much higher boiling point, not as commonly used as a solvent. It's a very common reactant, though, for making other benzene compounds. Next, OH on the benzene ring. We've seen this before. This is phenol. And if you have substituents on the ring, it would be substituted phenols or phenol derivatives. We've also seen aminobenzene, but nobody calls it aminobenzene. Instead, it goes by the name of aniline. Next, if there's a carboxylic acid on the ring, it's known simply as benzoic acid. Pretty straightforward. If you remember my recrystallization video from Organic 1, I recrystallized benzoic acid in that video using water as a solvent. It will dissolve in hot water, but upon cooling it will crystallize out. Has limited solubility in water, largely because of the large portion of hydrocarbon from the benzene ring. If there's an aldehyde on the benzene ring, it's called simply benzaldehyde. Now, benzaldehyde is a liquid. In fact, everyone here is a liquid except for benzoic acid. Toluene's a common solvent. Anisole sometimes, rarely a solvent. Phenol and aniline are too reactive to be solvents, typically. They're more reactants. Benzoic acid is a solid. Benzaldehyde's a liquid, but it's quite reactive. It's never going to be used as a solvent. Finally, we have acetophenone, also a liquid. Benzene ring with a methyl ketone. Now, if we had two methyls on the carbonyl, sort of dimethyl ketone, we know that that's acetone. So this is sort of a blend of acetone and the benzene. And when benzene is a substituent, we call it a phenyl group, and we'll see that on the flip side here. So it's a combination of these names. It's acetophenone. Again, it is a liquid, but it's not going to be used as a solvent typically. Although it could be. Okay. Now the solvent information is just sort of extra information. The solid, liquid, that's sort of extra information. The main thing here is you need to know these common names for these 7 benzenoid compounds, monosubstituted benzene derivatives. They're very common in the lab, often encountered in the lab. Okay, naming. Well, we want to use a common name when possible. Okay, one of these common names when possible. Look at this compound. Now, bromobenzene is not a common name. That's more of a systematic name. But there we have benzoic acid, a common name, and that's what we want to use. And this is benzoic acid with a bromine. Now, the bromine is in the 3 position because the substituent of the common name is by default the 1 position. Okay? If you're going to name it toluene, the carbon with the methyl is always the 1 position, no matter what. If you're going to name it as a benzoic acid, the carbon with the carboxyl group is the 1 position. Thus, the bromine, we would then want to go lowest number possible. That would be 2, 3. And so we have 3-bromobenzoic acid. That is 2 words. Now, we could call it metabromobenzoic acid because the 2 groups here are in a meta relationship. But again, that's, for us, that's going to be sort of slang. We want to use the numbers. That's more systematic, more IUPAC. But certainly it makes sense that this could be called metabromobenzoic acid. Let's do a couple of other examples with common names. Do we see a common name in here for a benzene derivative? Again, nitrobenzene is not a common name, but we see toluene there. Toluene. And that's the one position. The substituent of the common name is the one position. Then this is 2, 4, 6. So the name of this compound becomes 2,4,6-trinitro-toluene. Because we can just lump the nitros together, indicating where they're positioned, 3 of them, toluene. Now this compound, by the way, is TNT. Trinitro-toluene. TNT. It's dynamite. Okay. So, I know you've probably heard of TNT before. Now you know where that comes from. Let's try a couple of more. Do we see a common name here? Chlorobenzene's not a common name, but that's aniline. And that's the 1 position. The chlorine's at the 2, 3, at the 4 position. 4-chloroaniline. Makes sense, yeah? Over here. I actually see 2 common names here. That's benzoic acid. That's phenol. Now, I'm not going to expect us to know how to determine which takes precedence. I know that the carboxylic acid is the king of functional groups. It takes precedence, and so this is named as a benzoic acid. And there is so that's the 1 position, common name, 1 position. 2 position is a hydroxy. And we could call this 2-hydroxybenzoic acid. Makes sense. But the main reason I give you this is because this actually goes by another common name. There's lots of different common names for benzene compounds, including those that are monosubstituted, disubstituted, trisubstituted, etc. But this is called salicylic acid. And I just point that out because maybe you have heard of salicylic acid or salicylates. If we put an acetyl group on this oxygen, it will be acetyl salicylic acid. Some people say acetyl salicylic acid. Most people just call that aspirin. Okay? So I just wanted to sort of show you that because it's a very common term there. Before we go on, I've got one here. I've got a bottle here. I reckon this shows up. This compound here is 2-bromo-5-nitrotoluene. Okay? 2-bromo-5-nitro toluene. And let's try to go the other way. Let's try to draw this structure. Of course, that's toluene. It's got a 2-bromo, and it's got a 5-nitro. And there you go. That's this compound here in this. It's a solid. Toluene's a liquid. But with these 2 other substituents, it is a solid. This is 1, toluene, that's 2, 3, 4, 5. Pretty straightforward. Okay, flip side. Benzene ring as a substituent. We've mentioned several times, including Organic 1, when the benzene is a substituent, it's called a phenyl group, pH. Now, P big H, that's pH like acid-base pH. This is not like that. Typically small letters or whatnot, but phenyl group. For example, this is a pyridine ring. Okay, we'll see that later in the lecture. Pyridine with a benzene coming off. Now the pyridine takes precedence here. Don't really need to know that. What we have is a pyridine with a benzene ring at the 2 position. The nitrogen's the 1, and that's the 2 of this ring. We don't call this like 2-benzene pyridine. Instead, we use the term phenyl, 2-phenyl pyridine. So I'm just illustrating the use of phenyl. You remember this compound from Organic 1, we brominated it. We called it trans-stilbene. That's a common name. IUPAC would be 1,2-diphenyl ethene. Actually, that's missing something. We need a trans here. Because you could also have the cis version. There's ethene. That's 1, that's 2. 2 phenols. One's on the 1 position and one is at the 2 position. So, use of phenyl as a substituent. Now when you have the benzene ring and a CH2, that's a benzyl group. Then something coming off. For example, this compound is called benzyl chloride. This compound is called benzylamine. Again, here I drew the benzene ring out. Here I designated it as a phenyl. Same thing, there's your benzene ring. All right. Same way here, benzene ring, then I did phenyl, just to show you 2 different ways. If we had the benzene ring CH2OH, that's called benzyl alcohol. We mentioned benzyl in Organic 1 because that carbon there, it's a great place to form carbocations and radicals, etc., because they'll be resonance stabilized through conjugation with the benzene ring. Here, that carbon is called the Benzylic position, or the benzylic carbon. We can use this terminology to ask questions such as this. How many benzylic hydrogens does the following compound have? How many benzylic hydrogens? I'll let you answer that. I'll also let you name this compound for good practice. Name that compound. Okay. I added one additional here. One additional common name. And I do want you to know this. Over here had 7. I'm going to make it 8. I want you to know this one. Now if there's only one OH there, it's phenol. 2 OHs in a 1-2 relationship. And so that's ortho. An ortho relationship is known as catechol. It's catechol, not chol, but catechol. OL ending sort of because it's alcohols or phenols. Okay, so that's catechol. a common name. The reason I want to add this, and I want you to know this, is because you see catechol in lots of biochemical compounds. Neurotransmitters, such as dopamine, have the catechol portion, but then something else coming off of the catechol here, of course, and then some type of amine. And these are called catecholamines. It's a very important class of neurotransmitters. Very applicable terminology there in nomenclature. Okay, so this is nomenclature of aromatic compounds. Halogens and nitro groups named as sort of standard systematic naming the substituents, pretty straightforward. Identifying the one position, lowest numbers possible. Common names, 7 here, plus catechol, 8. If you can find a common name, use that, like we did. You do not have to be able to choose which common name here. I'm not going to ask you to do that. I just showed you that because salicylic acid itself, a common name, is very common. And I wanted to show you how salicylic acid does have a alternative name which should be pretty straightforward. Then we saw phenyl, benzyl, benzylic. Okay. So name this compound here and determine how many benzylic hydrogens are there. And we'll answer that in class. Okay, guys.